Okay, so the steps say, number 1, isolate the exponential equation. The first two here, we don't have to worry about that. They're already isolated. Step 2, I don't really like the way that this teacher phrases it, so I put in parentheses on your paper. Instead of taking the log of both sides, we write it in logarithmic form. Okay, that's why we went over logarithms, was so that we could go from exponential form to logarithmic form. So we're going to write it in log form. So then step number 3 really doesn't apply, but then after that we may need to do a couple extra steps to get the variable by itself to solve. We do need to check for what are called extraneous solutions. We've talked about those a little bit. Sometimes you get an answer, when you plug it back in, it doesn't work. So you should always check your solutions. Now, we're going to get an exact solution for all these, and then we're also going to find an approximate solution, because I've seen it go both ways. I've seen the answer in log form, and I've seen the answer in decimal form. So we just need to know how to put it in both forms. So let's look at example number 3. That exponential is already isolated, so we don't have to worry about that. We cannot write 61 so that it has a base of 2, so we need to write this in log form. So remember, log form, the base of the log is the same as the base of the exponential. The purpose of log form in this case is the variable is stuck in the exponent. The only way to get it free is log form. So that means the 61 goes inside the logarithm. The x is on the other side of the equal sign. Now, in this case, it's equal to x. So that is solved. That is our exact answer right here in log form. Log base 2 of 61 is the exact answer. But what if they give the answer choices in decimal form? We need to use our change of base, log of 61 divided by the log of 2, and go to our calculator and find out what the decimal value is for that. Log 61, parentheses, make sure you close your parentheses. If you don't, it's not going to give you the right number. Divided by the log of 2. So 5.931 is our approximate answer. So exact is in log form, log base 2 of 61. 5.931 is the approximate answer, and we can always check it. 2 raised to the easiest thing to do is just to press second answer, second negative, and that puts the answer in there, and it gives us exactly 61. If you put your rounded answer in there, I want to show you what it looks like. It gives you something very close to 61. It's just not exactly 61 if you put the rounded approximate answer in there. Okay? Any questions about the calculator? Okay, let's keep going. Number 4, 8 to the m minus 7 is equal to 92. Again, that exponential is already isolated. The variable is stuck in the exponent, so the only way to get it out is to write it in log form. The base of the exponential is the base of the logarithm, so log base 8 of 92 is equal to m minus 7. The variable is not by itself this time, so we need to add 7 to both sides to fix that. Now, here's something that people like to do. They love to add 92 and 7. But that 92 is not by itself. It's inside of a logarithm, so we cannot actually combine those. We just have to write the plus 7 at the end of that log expression. So there is the exact answer for our variable. To find the approximate answer, use your change of base, log of 92 divided by the log of 8, and we're going to add 7 to the end of that, making sure that we close our parentheses after the 92 and after the 8, and then add 7. We get approximately 9.175. So there's our approximate answer. After I get that, I'm going to plug it back in. 8 raised to the parentheses, because there's more than just the variable in the exponent. The answer minus 7, and it gives us exactly 92. Okay. So that's the way I do all these problems. I get my log answer, I find the decimal value for that, and then I check the decimal value to see if it's correct. Okay, number 5. The exponential expression 7 to the nth is not by itself. It's being multiplied by 4, so we have to isolate it first. We have to get it by itself. So how do we move that 4? We divide, because we're multiplying, so the opposite of multiplying is dividing. So we've got 7 to the n is equal to, what does that give us? 37. Thank you. At this point, you should still always ask yourself, can I write those so that they have the same base? We can't. 37 is not a power of 7, so then our only option is to write it in log form. Log base 7 of 37 is equal to n. That's our exact answer. Let's get the approximate answer. Again, I like to write it out so that y'all don't forget how to do change of base. It's such a simple thing, but so many people forget how to do it. So hopefully if you write it every time, it'll stick. So 1.856 is our approximate answer. Check it. 4 times 7 to the answer, 148. There we go. All right, number 6. The exponential expression is not by itself. I think it kind of helps to circle that exponential expression. It helps some people see what's outside of it and what they need to move. So we've got a minus 5 stuck on the end, so we add 5 to both sides. 4 to the 3w is equal to 8. What can we do here? We can write them both as base 2. 4 and 8 are both base 2. 2 squared, 2 cubed. Now, here's the good news. If you didn't notice that they could be written with the same base, if you're just on this whole idea of putting it in log form and going from there, it's fine, okay? It will still work out. If you wrote this in logarithmic form and then divided by 3, guess what? You would end up with the same answer. You would end up with 1/2 as your answer. So it's not the, I would love for you to recognize when they have the same base, but it saves you some work if you do. It's not quite as much work if you don't have to deal with the logarithmic form and then typing that into the calculator and all that stuff and making sure you get parentheses in the right spot. So it's better if you recognize the same bases, but if not, it still works. So what I'm saying is, if right here you wrote it log base 4 of 8 is equal to 3w, and then divide by 3, and then type that into your calculator, log of 8 divided by the log of 4 divided by 3, you still get 0.5, or 1/2. Okay, you still get the same answer either way. Okay. Questions so far? Pretty simple, right? Okay, let's flip it over. Do some more examples. Look at number 7. 7 minus 4 to the x plus 1 is equal to 18. So I'm going to circle this exponential expression right here, just to point out to myself what all is going on in front of it. So the first thing we need to do is we need to subtract 7 from both sides. So we've got negative 4 to the x plus 1 is equal to 11. Is the exponential by itself yet? No, it's got a negative in front of it. How do we fix that? Divide by negative 1. 4 to the x plus 1 is equal to negative 11. So we ask ourselves, can we write that so that we have the same base on both sides? Obviously the answer is no. Does anything look a little weird about this one? It's equal to a negative number. Is that possible? Can we raise positive 4 to a power and get negative anything? No, we can't. So at this point, we don't even have to go any further. This is no solution. Okay, this one has no solution. If you didn't check that, let's go ahead. Let's do this just so that I can show you what would happen. If you didn't catch that it should be no solution because you can't raise 4 to a power and get a negative number, write it in log form. Log base 4 of 11 is equal to x plus 1. Subtract 1 from both sides. Log base 4, negative 11 minus 1 equals x. When we go to put this into our calculator, log of negative 11 divided by the log of 4 minus 1, and I press enter, I get an error message that says non-real answer. Okay, it's because you can't take the log of a negative number because you can't raise 4 to a power and get negative 11. So it's no solution. All right, number 8. We need to begin by dividing both sides by 10. 5 to the 3k minus 3 is equal to 4. 5 and 4 cannot be written with the same base, so log base 5 of 4 is equal to 3k minus 3. Add 3 to both sides. Log base 5 of 4 plus 3 is equal to 3k. Then divide the entire thing by 3. You got to make sure you divide the whole log base 5 of 4 plus 3. You divide that whole thing by 3. So here's how you got to put it into your calculator. You kind of have to do it in pieces. The log of 4, close parentheses, divided by the log of 5, close parentheses. You can go ahead and put the plus 3. But since the whole thing has to be divided by 3, you need to put the whole top in, press enter, and then divide by 3. So it is approximately 1.287. If you try to type all that in at one time and you don't put parentheses around that entire numerator, you're not going to get the right decimal approximation. So 10 times 5 raised to the parentheses, 3 times the answer, minus 3, close your parentheses, we get 40. Okay? So make sure you're careful when typing that in to get your decimal. Okay, we're going to do a couple more and then I'll let y'all try a few because these really aren't hard. I just need to show you some of the technicalities. On number 9, 3 to the n, we're trying to get that by itself. So we need to start by subtracting 15 from both sides. So we've got 4 times 3 to the n is equal to 344. Divide both sides by 4. 3 to the n is equal to 86. Is that right? 86 is not a power of 3. It's really close. 81 is a power of 3. So log form, log base 3 of 86 is equal to n. Exact answer. Approximate comes from change of base. Log 86 divided by log of 3. This is approximately 4.055. Check it. 4 times 3 to the answer plus 15. Notice I don't need any parentheses on this one because the variable is by itself in the exponent, so I can just put the answer there. I don't need any parentheses or anything because plus 15 is not inside that exponent. Okay, let's do one more. Number 10. Subtract 7 from both sides. Negative 2 times 5 to the p equals negative 70. Not looking good so far because it's equal to a negative number, but this will remedy it. Dividing both sides by negative 2 gives us positive 35, so we're in the clear. Log base 5 of 35 is equal to p. Exact. Log of 35, close parentheses, divided by the log of 5, approximately 2.209. Check it. Negative 2 times 5 raised to the answer plus 7, negative 63.